Right, equations involving compound formula, challenging question. There's two issues here with this question. One ratio is cosine, the other is sine, and also the argument is different for both. So in order to solve this type of equation, we have to take advantage of compound angle formula and change one ratio and to the other, and attaining the same argument for both. So we'll get some consistency, and then we'll be dealing with, for example, quadratic equation that we can do by substitution. So let us begin with resolving sine pi over 3 minus x. So this is additional work that we have to perform before we start solving. Pi over 3 minus x sine. So this is the difference, the subtraction formula. So this is sine pi over 3 cosine x minus sine x cos pi over 3. Okay. And again, sine pi over 3, if you recall ratio, so think of it as 60 degrees. So this is root 3 over 2, and the root 3 over 2 ratio is equivalent to cosine pi over 6. So this is something that we need to know in order to be successful in solving this type of equation. So sine pi over 3 was converted into cofunction cosine pi over 6. Same equivalent ratio minus sine x, and cosine pi over 3 will be converted into sine pi over 6. So cosine pi over 3 is half. Sine ratio pi over 6 also has a value of 1 over 2. So what we did now, we have cosine minus sine sine. So this should remind you of sum of cosine. So this is cosine pi over 6 plus x. Okay, so sine pi over 3 minus x is equivalent to cosine pi over 6 plus x. So this is why this equation will be modified slightly. So the first term unchanged, sine pi over 3 minus x is replaced with that, and everything else just copy. So now we have a quadratic type of equation when we'll say that cosine x plus pi over 6 will be replaced with a new variable. So let cos x plus pi over 6 be, say, y. So now we have 2y squared minus 3y plus 1 is equal to 0. So at this point, we should all be excited because we have quadratic equation and we know how to do it. So when you solve it, either by factoring or using quadratic formula, you'll get two roots. So y will be equal to 1 over 2, or y will be equal to 1. So then cosine x plus pi over 6 is either half, it's 6, let's fix that. So this is either equal to 1 over 2 or cosine of that same angle, 6, is equal to 1. So remember, the domain is 0 to 2 pi. Cosine ratio is equal to 1 over 2. So the angle x plus pi over 6 is equal to pi over 3. Or that angle x plus pi over 6 and the fourth quadrant is equal to 5 pi over 3. How do we know that? 6 over 3 pi is 2 pi, minus pi over 3 will get you that. Over here, cos x is equal to 1. So cos x is equal to 1 when cos of an angle is equal to 1 when that angle, in our case x plus pi over 6, is equal to 0, or that angle x plus pi over 6 is equal to 2 pi. Okay, so now supposedly we have 4 roots. And let's finish off and solve for all 4. So from the first one, so I'm going to call it x1. The x value will be pi over 6. All right. Root number 2, when you take away pi over 6 from 5 over 3 pi, you get 9 over 6 pi, and then that simplifies to 3 over 2 pi. So x2 will be 3 over 2 pi. Root number 3, x would be equal to negative pi over 6. However, our domain is from 0 to 2 pi. So unfortunately, we're going to say reject. So this is not admissible value. Okay. Root number 4, 2 pi minus pi over 6, and that will give us 11 over 6 pi. So in total we have 3 roots to that equation. Very interesting equation, challenging equation, but once you know compound formula and you realize that ratio of sine and cosine for certain angle has the same value, like you switch from 30 to 60 or vice versa, then you can quickly cope with the challenges here. And converting to quadratic equation was the most challenging step. Then solving quadratic equation, not as very difficult. And at the end, 4 roots, identify 4 of them, make sure that they all fit into our domain. Thank you very much for watching, and I see you next time. Bye-bye.